Welcome back. Perfect. Guys, a new quiz is going to open by the end of the lecture, and you have until midnight to complete the new quiz, the core, class diagrams, and the relationship between classes. So please, by the end of the lecture, you can open the quiz. It's 30 minutes. It's really quick, but you have the full day just in case you want to review the concepts, the things that we review in the previous lectures, class diagrams, relationship between classes, and being able to identify the difference between the diamond, the triangle, and a common arrowhead. So review that, complete your quiz. Next, questions about your assignment. You are working in the assignment, you work the assignment, any question? We do not have any context yet about the syntaxes, about the position of the things. So what we are doing basically is put together characters, and the first thing that we discover in that combination of characters, that is what we report.
Okay.
So for instance, just to give an example, if you have something like 0b100 equal to 53, that do not make sense. Is a value equal to another value, but do not make sense in terms of the syntax. But what we are doing right now is, okay, this one is a binary number, this one is an operator, this one is a decimal number. That is the only thing that we care.
Okay.
Good. Okay. The answer for the quizzes, yeah, you can contact the TA, just ask her to open the answers. You can have access to that. Usually 1 or 2 days after the due date, you have access to that. Good. That one is an error. Very good question. What if you have 0, B, 1, 1, A, B, C? That should be reported as an error. Because remember, always try to create the longest word. So here you have 0B, should be binary, 1, 1 is binary, everything go okay. But then you have letters, and you have letters without any delimiter here or space or whatever. So you continue putting things together, and at the end, doesn't matter what happened, all this combination is an error. This one without the spaces is correct, 3 words. It doesn't matter if you have spaces here or not, because again, you are putting together the characters. So the equal is an operator, the operators are the limiters. Every single time that you have an operator, they delimit words, they cut words. This one is another one that I receive in a question, A, B, C, like that. And then without the spaces, A, D, D. Those are 2 strings. Open quotation marks, closing quotation marks, that is a string, just because you have the quotation, whatever inside, that is a string. And then you start again, quotation, whatever, quotation, 2 strings. It doesn't matter that you do not have delimiters, it doesn't matter that you do not have spaces, it's just 2 strings because the quotation marks are like the operators, like the delimiters, things that cut the words. Good? No, you do not need to handle cases like this, A, B, C, and then you have C, D, E here. I'm not want to make this more complex. So in this case, if you have 2 lines and you start the string in 1 line and then you follow the string in the second one, I am okay if you report 2 errors, that could be the case, or if you report 1 string. Different languages work in different ways. Depending on your implementation, depending on how you are reading the characters, I could be okay with both. Probably with the implementation that you already have, this is going to be 2 errors. The first one do not have closing, and the second one do not have something to open, but yeah. In the class diagram, there is no particular order regarding publics or privates. Usually what the tools are going to do is to give you alphabetical order for the names of the methods and alphabetical order for the name of the variables. So it's easy to find a particular name, and the plus and minus, as they should be public or private. Most of your variables, again, should be private. Most of your methods, or a good number of methods, public. Good? Okay, any other case that you think about it, send me an email and I can tell you which could be the expected output. So go ahead, talk with your team, or if you're working alone, just figure out examples. One very good test that you can do, and usually recommend, take your program, the source code of the program, and use the source code of the program as an input, the source code in Java, and see what happens. That could be your long test. It's a lot of lines, it's Java, but it should work. It should give you some good reports. Okay, moving forward. Previous class. Previous class, we were reviewing this idea of patterns. In particular, I talked with you about the observer pattern, the idea, and also the implementation. For the implementation, I want to be sure that you remember, we need 4 classes. 2 abstract or interfaces, whatever, and the 2 concrete elements. We reviewed this idea with this guy and this guy being the Pac-Man and the ghost, or a panel and a source of data, a data source. We talk about the listeners, and these 2 being like the widget that we want to know if something happened with that, and the class that need to know that information in order to do something, to trigger some kind of action. To submit the assignment, there is going to be a link on Canvas. I can review that later, but you have a link you need to submit there. In the link, you can submit several different things. My request for you, 2 things. Number 1, the source code. The source code is use the Java source code. You do not need to use packages. You can put everything using one package. So it uses a set of Java files. You can put them in a zip, or you can submit them individually. Both options are okay. And also you can submit a PDF file with the other information. So several files that you're going to be able to submit on Canvas. I need to review if the link is enabled, but you're going to have a link for that. So moving forward, subjects and observers. We reviewed this, and in the previous class, you can review. I implement with you all this, the 4. In reality, we do not want to implement more than what we need. Good news, several different languages, including Java, provide in the libraries elements that you need to work with the patterns. For instance, here, working with Java, you have this one and this one as library classes. So you only need to worry about the 2 classes that you want one to share information with the other. And the other 2 classes, the interfaces, they are available in most of the libraries, or in one library in your particular language. So talking about Java, in the previous lecture, I showed you the implementation from scratch, the idea. I want to talk now about using the Java API to implement the same, and review another example. So implementation of the observer in Java. By default, you have until Java 8, the implementation of observer in the package Java util. So you can work with observer. The only thing that you need in your programs is to import Java util. There, you're going to have observer and subject. Well, subject is going to have a different name. I am going to use Java to implement an observer relationship between 2 of my classes. And my classes, my program, is going to have a student and a tutor. I am going to implement this idea of, you know what? I have a class student and I have a class tutor, and they are in a classroom. And obviously the student is going to be observing the tutor, or if you want, the tutor can observe the student. Somehow one of them have information that other of them need. That is the perfect scenario for an implementation of observer. 2 classes, one need information from the other. I do not need to worry about the relationships in the low level. The only thing that I know is I need an observer, period. Observer, this is my scenario. Hopefully you agree with me in terms of class diagrams. In terms of class diagrams, I am going to use different colors from the library and from my classes. In terms of class diagrams, what I am asking is I have a class student and a class tutor. They live in a classroom, just because the example that I give you. If you think about having a system with 3 classes, the class student, the class classroom, and the class tutor, which one have the method main? Which one is going to be the principal class here? The one that is going to be the beginning of the program. Where do you put the main? Notice that I haven't talked about what is going to happen here. It's just 3 classes, student, classroom, tutor. Where do we put the main? I can agree with the chat. Can you agree that probably what you can do here is a class, classroom? Classroom is what your IDE usually call the main class or the universe class or the world class. Is the class in which you are going to have the main method. What are we going to do in the main method? Can you agree with me that we need to create an object student and an object tutor, or maybe several students and several tutors in some place? If I create here in the main students and tutor, one or more, they are local variables, right? If they are local variables, what is the relationship between classroom class and student and tutor class? Association. That is the reason because these arrows, there is no diamonds involved unless I put attributes. Be careful with that. Again, I have the news, I am going to create objects, but if I keep the object local variables, my relationships are associations, and that is good. So association between classroom, student, and tutor, I can create here the objects. The next step, the observer pattern. The observer pattern, somehow here, after creating the objects, I need to specify who is going to be observing who. But we're going to do that later. The other thing that I need to do, I am going to create my class student and my class tutor. Inside of those classes, you're going to put the variables and the attributes that you need according with the responsibilities of those classes. But because we're following the observer pattern, the mandatory thing to do is this inheritance. Inheritance, it could be generalization, specialization, or realization. For the implementation of the observer pattern in Java, in the Java API, what they do is they give us the observer as an interface. It's an interface, remember? The only thing that I have there is this signature for the method update. Nothing else. It's an interface with one method update. The only thing that I need to do is if a student is going to need information from tutor, student is going to implement the interface observer. Done. Help me, what is the difference between the dash line and the full line? We reviewed this in the previous lecture. What is the difference here? Anyone? Dice line, implement. Solid line. Good, that is the difference. Okay, so this one is an interface, and this one is going to be implements the interface. So just remember, public class student is going to be doing an implement of observer. On the opposite, we have what we call it, what the original patent called the subject. Java changed the template. In Java, instead of using the name subject, Java called it observable. The subject, the observable. The book, the template in the book, call it subject. Java prefer observable. It's the same, different names. Moreover, in Java, observable is not going to be an interface. Observable is going to be a class. An abstract class, still a class. Can you tell me why? Why observable should need to be a class, not an interface? It's about what do we have inside here. Do you remember the content of the class subject, observable? What do we have there? Observer is used an interface with this update empty. But do you remember subject? Observable? What do we have there? Attributes, which ones? Do you remember that we have a list of all the observers observing this guy? Do you remember that a subject needs to remember who is observing me? And in order to remember that information, we put a linked list of observers, a variable, and that basically all these methods, the add, the remove, the notify, are working with that data structure to add elements, remove elements, or traversal the elements. If we're going to have attributes, what we need is a class. If you want an abstract class, but it's not an interface. So in Java, observable subject is a class. That class have these attributes, the linked list of observers, and therefore provide these methods. The methods add and remove. In the original template, you call those methods attach, detach. Java used different names. Add observer, remove observer. I think made more sense. Add and remove what, instead of use attach, detach, the generic name in the original template. Moreover, Java include this set change method and the notify observer with that particular name instead of just notify. This, the Java API, the two blue boxes, is something that you have in the libraries. The only thing that you need to do is implement this one and extend the other one. One is the subject, the tutor. The tutor is going to be this subject, this observable thing. The students are going to be the observers. The students are going to receive information from the tutor. Yep, that is possible. Again, the decision in the Java API, the decision that they take is these guys, the observable, is a class, not an interface. One and one interface, one abstract class. Main idea for them, these methods have a body. And usually the decision of a pure interface is we have methods without bodies. For them, in order to identify, here we do not have a body, never, update is empty. Here we have bodies, add observer, notify observers, even remove observers. those methods have a complete body. They are working with the attribute, the data, the list of observers that we have. So just because I have that, the decision is, well, this is somehow a class. If you do not want to allow objects from this class, put this class abstract. But this one makes sense as a class. It's not just a simple, trivial, empty interface. So that is the criteria behind Java implementation of Observer. Again, one thing is the original template. This is what Java decides to do with the template and provide to the developers. So Observer and Observable, one implements, the other extend. Already Observable give you the data structure and the methods to work with the data structure, and Observer just give you the update. If I implement this, I will have information moving from a student to tutor. Okay, programming. Source code. Number one, student. Student is the one that needs information, is going to implement the observer. The observer, we're going to use the Java API, so we do not need to create our own class. Import Java util, and the two classes that I am going to be using is observer and observable. So I just put there the two imports. What do I need to do in this class is whatever this class originally do, plus this override here. It's just like when you implement listeners, your responsibility is to provide a particular method. Here, when you implement observer, your responsibility is to implement the update method. Now, the update in Java, you will notice a particular thing that happened, a particular thing that is Java implementation. What is that? Did you notice this student is going to be an observer? I am going to be an observer. And my method update is going to be called every single time that the information that I need change. I am going to receive a call. This method is going to be called from somewhere. I don't care who is going to call it or how, but the method is going to be called when some information that I need change. In Java, I am going to receive as a parameter this. And what is that? It's a reference, right? It's a reference to who? The reference to the subject. Why? Because in Java, I can be the observer. I'm interested in observing not only one subject, but maybe several. Right now, I am an observer, and each of you, the one that I have in my screen, you are the observables. I am observing you. I ask you at the beginning, guys, I am interested in observing you. All of you have my reference in your memory, knowing that I am interested in your information. When some information is important, you are going to call my update method, this method. But because I am observing several of you, when you call my update method, a parameter that you are going to send to me is your reference, your name maybe. So I will know that some information that I need change, and also I am going to know who or where that information change, which is the person, the object that I am observing, and that is telling me that something changed, that something get updated. Yeah. The important thing here is, just because Java gives me the reference of the observer, the observable, automatically I know that this reference, I can use it to call a particular method. The good news with the Java implementation is that if I am observing several, I know which one changed. But even if I am observing only one, just because I am receiving the reference to that one as a parameter, automatically, I do not need to have a global variable here with that reference. I use what I receive as a parameter, and with that one, I can call a method in that one. It's like I am a student, and I just receive a notification that the tutor do something. I receive the notification, and what I can do is to call a method in the instructor and, hey, can you repeat what you said? Because I have the reference, I know who speak. I receive the notification and then I can establish a communication. That is the Java implementation. So if I am going to be an observer, the only thing that I need to do, implement the observer interface, provide an update method. In that update method, I am going to receive information about who was the subject, who was the observable. If you review this, it's exactly the same that happened in your listeners. When you implement an action listener, in the action listener, you receive as an object, as a parameter, the source of the event, remember? And you can know where that event happened. Easy. Same process. Now, nothing happened here. I can establish communication, and then I am going to receive an answer, and I can store that answer, and I can work with that. Communication between objects. What's happened with the tutor? What's happened with the observable guy? In the observable guy, that one is going to implement, that one is going to do extend, not implement. Again, observable is a class. I need the package. Everything else is just whatever is the functionality of the class. There is nothing here related with the pattern except those two lines. Where those two lines are going to be, whenever in any place that you need it. I have this tutor, and this tutor have a method, ask a question. I am a tutor. One of my methods is ask a question. And you know what? When I ask a question, I want all my students to be notified that I am asking a question. Ask a question is that line. And the notification to all my observers that I have a new question is these two lines in red. Two lines in red. Call the method setChange. Call the method notify observers. Just like that. Where are those methods? Here. I am inheriting those methods from observable. I am calling two methods that I inherit. And those two methods are going to call the updates in my students. Because of these two methods, the students are going to be notified that I am asking something. The only thing that I need to do. Question, can I have another method here? Whatever. And can I call here setChange and notify also? Can I call setChange and notify not only from ask question, but also from this method M? Can I call setChange notify from two different methods, or three, or four, or five? Yes or no? Yes. You call these two in any method, in any moment in which you want others to know that you change something in the information. That is observer. Now, put things together. Following the implementation of observer in Java, do you remember? Classroom. no attributes, so no diamonds in the class diagram. The method main, everything is going to be local. I am going to create a student. I am going to create a tutor. Did you notice? I am creating a student and tutor just like any other object. In the main, I do not care if they are observers, observables, or what is happening. They are just two objects in my program. The only thing that is new, the moment in which I discover that here I am using some particular pattern, is this line. Use one line. Tutor, add observer. Tutor have a method add observer? Yes. Tutor inherit that method from the observable class. We apply inheritance, remember? So tutor add observer, observer who? Student. I only have one student here, so one student. Done. From here down, what I have is this structure in which the object student is observing the object tutor. Whatever I do below is just work with my objects as usual. For instance, this one, just for fun, I put a for loop. In the for loop, I am calling the method ask questions. So this tutor is asking 5 questions, and 5 times the object student is going to receive a notification. There is a new question. And the student is going to be able to ask back, can you repeat the question? So 2 classes that share information. Done. Questions so far?
Professor, I have a question.
Yeah, please.
Can one observer observe only one observable at one time?
Again, please.
Can an observer observe more than one observables at the same time?
Yes, you can be an observer and you can be observing more. Both are correct. I can be an observer and I can be observing more than one observable, or
Okay.
I can be an observable and I can be observed by more than one observer. Both can happen.
And Professor, in the observer class, you are casting the object to tutor object as soon as you're receiving it. So what if there are more than one observables, like tutor and one more class is observing this one? So you're directly casting it to tutor class. So if it's not a tutor class, won't it be an error?
The second parameter. In the second parameter, you can send as a parameter an object. An object could be like a string, and that string could be something that is an ID between different types of observable. I didn't mention the second one, but your second one is your solution for that particular problem.
Okay, got it. Thank you.
Good. So, for instance, question in your exam, what happened if here I want a classroom with not only one, but 2 students? So now I have the student 1, and probably I want to have a student 2. And it's like, okay, now you have the classroom and now you have 2 students. What should I need if I want student 2 also observing the tutor? If I want the tutor connected with student 2 also. Hopefully you agree with me. Well, if tutor is being observed by student 1, I can do tutor, another observer. And now what I have is tutor as a subject, tutor as an observable. And I have 2 of you, 2 students as observers, both of you observing this tutor. Do I need to do any other thing? That's it. What if I need 100 students observing that tutor? Create 100 methods, and for that 100, run an instruction like this. A list of students could be great. Moreover, instead of having these 2 lines, probably you would like to do something like in your list of students, the element index And this could be the parameter for add observer, right? The point is, you do not need to worry about how many observers or observables you are going to have because you already create the full structure. In the main, you just add. And also the opposite, I have a tutor one and tutor one have that. But what if I create a tutor two? And well, now I have two tutors in the classroom. And now I would like to have this tutor two being observed by student two. If I am a student two, I am observing that tutor and that tutor. So I am observing two guys, two people in front of the classroom. But moreover, if I am the tutor one, I have those two students observing me, the student one and the student two. And if I am tutor two, I have only one student observing me. For some reason, student one is not observing me. Student one do not care about me. You can connect the relationships in any way that you want. Again, all the structure is there. Make sense? Questions so far? Good. Okay. This should be the output of the program, just for you to notice the prints are in the student class. The student is the one printing the information. The tutor is the one that creates the information. That's a very good question. And that is a question in your quizzes or in your exams, the tricky one. Help me, what do you think a class, the same class, can be observer and observable? Yes or no? Exactly, that is the answer. Yes, it can. Why? Because in order to be one, I use implements. In order to do the other, I use extends. One class can implement an extend? Yes. If in Java we use extends for both, in that moment we cancel the possibility of multiple inheritance. So one class could be only one. But just because we are using one interface and the other a class, it is possible for one class to be at the same time the observer of another class, but being observed by another one. So you can create this kind of connection. I am observing, receiving information for someone, and another guy is checking my information. The assumption is that somehow I modify the information, that there is a reason because that third person is observing me instead of observing the original source of the information. But again, answering the question, it is possible? Yes, it is possible. You need to check your particular problem, your particular design, whether or not you want to do that. One subject, one element being observing and observable. But yes, it's possible. So, big parenthesis, big note. If you're working with Java and you use the observer pattern, you're going to receive a message about depreciation. Only if you are working with Java 9 or above, please don't worry. My IDE is telling me that my observable didn't work because they are depreciated, and I have this big yellow triangle in some place. Just ignore that. What happened? Java 9 and above, one of the improvements of Java 9 and above is to take more seriously the multi-threading part. We're moving to a multi-threading model. The observer and observable, as they are defined in the book, as I showed you, all the source code, we do not really care about multiple threads running. We do not care about this observer observable being different threads of execution. So in Java, the original implementation, this implementation in Java util is considered depreciated. Is considered, hey guys, do not use that one. Why? Number one, they are working in a different one for the Java util. But in the meanwhile, the recommendation that you are going to read is use this. And hopefully make sense the name, property change listener. Remember, listeners and observers is the same philosophy. Java called them listeners. So there is a listener that is called property change. Property change. So the value of a property attribute change, and we're going to have a listener for that. And that is observer. Yes, that is observer. But we need to change the name because we already have observer, observable in a different class with a different implementation. So you can use observer and observable. My examples are going to be with observer and observable because we are not working with threads. I do not care yet about threads. We're going to work with that later. So observer and observable are fine. But if you want to move forward with Java 9 and update your things, property change listener is better. And you're going to find the same philosophy. Implement the listener, provide a method. That's it. Good. So you can ignore that message. That is the summary for this. Don't worry for the depreciation. Okay, so another example, I need your help. I want to create a program. And I want to create a program, and in this program, I want to have 2 panels. I am recording, right? I think so. Okay. Hopefully, yes. If not, okay, good. So I want this. Yeah, I think so. Okay, I have this program. And my program is very simple. I would like to have this screen, a window, and I would like to have 2 panels. In one of the panels, I would like to have an image, that image, a text field, and the bottom to click. What I want to do is, in this panel below, I can write here something, X, Y, Z. And when I click send, the only thing that I want is this information here to be printed in this panel here. So I have 2 panels, and I am going to input as a user information in one panel. And then I want that information, the same information that I put in the text field, to be printed in the other panel, in the panel above. That's it. And if I show you this problem, the first solution that you can come with as a novice programmer is a global variable. We create one class. In that one class, we put a global variable, and the global variable could have the information in the first panel, and the second panel could check the information in the global variable. Done. The problem is, if you put a global variable, immediately your program should be in one class, only one class. What happens if later I start asking for complex behaviors here and complex behavior here? You are going to continue having that 2 complex behaviors in the same class because you have this global variable that is sharing information about 2 of the panels, 2 of the elements. In some point, this program cannot be extended, or extending the problem is going to go down with the quality. A good design should split these 2 panels into different classes. And if we split these 2 panels in 2 different classes, my solution with the global variable is not possible anymore. Moving forward, I have 2 classes. Now I can share the information using methods. Either one method send the information as a parameter, or the other call a method and the information go back in the return. We are reinventing the wheel. If you have two classes and one class needs information from the other, observer and observable, done. Again, creativity is important, innovation is important, but if you have a problem and you have a standard solution, probably your standard solution is the first thing that you can try. And hopefully I make the case for observer in this problem. And if I make the case for observer, hopefully this class diagram makes sense for you. The problem, the blueprint for the solution. No code yet, but this blueprint makes sense for the requirements of my customer. Let's see. Number one, hopefully we agree that still classroom is going to be like the main before. Classroom is going to be like, well, classroom is the one connecting students and connecting other things. And we prefer to have association instead of composition. We prefer to use the arrow without diamonds. And I think that could be possible because we can create students and the tutors as local variables. Local variables are better than global. So if we can work with the local, that is going to be a good idea. We did it before. Hopefully we can do it again. The only new thing is now classroom have this triangle with the line, solid line. I am thinking that classroom could be a child from J-frame, and therefore classroom is going to be this window here. Now classroom is a graphical element, the frame. Good. Classroom is going to be a frame. Therefore, classroom could have inside panels. I am asking for a student. I am asking for tutors. And something that I can do is, well, that student, that tutor can extend from panel. So the student is going to have a graphical representation. The tutor also, they are going to be panels. Therefore, they can be added inside of the frame. They can be added inside of the classroom. So far, makes sense. Now, according with this, what you want is this professor to be a subject, observable. And this is the guy that is going to be observing what happened here because it's going to print whatever happened down. I want the student to be an observer. And just like before, observer, using the Java API, implements. Something that I want you to notice is when I look to the class student, the three relationships that I am reading there is like, this student is observing information from another class. This student have a graphical representation because this student is a panel. Moreover, this student is being used by a classroom. The three lines tell me what is going to happen with this particular class. And hopefully by now you can imagine the source code of the class. Just looking to the class diagram, my expectation is that you can imagine what is going to be the source code of this class, what is going to happen with this panel, what is going to happen with this observer, and what is going to happen with this relationship with classroom. What do you need to provide? It's like, I need a constructor, there are going to be extends, implements, because the implements, I need to provide a particular method, and somehow the idea of the cost of this class, the number of lines of code that you need to write, is something that start moving in your brain, hopefully. Tutor. For the tutor, I am doing something different here. For the tutor, I have a problem. I have a problem because I want the tutor to be a panel, but also I want the tutor to be observable. But we have this problem, inheritance in Java cannot be multiple inheritance. If we were working in C, I do multiple inheritance and I put tutor as the child of a panel and the child of observable, done. I will have exactly the same that I have with the student. In this particular case, I cannot do that, right? Java. Solution. If you have a class and that class need 2 parents, you cannot do that in Java. Split the class in 2. And half of the class is going to have 1 parent, half of the class is going to have the other parent. Common solution for Java multiple inheritance. Now, we need to connect these 2 classes. What do we do to connect these 2 classes? We create a variable here, and the data type of this variable is this class. Or the opposite, inside of this class, I create a variable from this class. And then they are connected. Now, the variable can be local or can be global. If the variable is global, the relationship is with the diamond. If the variable is local, then the relationship is used association. Up to you. But again, I need inheritance from 2 parents, split the class, and connect them with a variable, local or global. Then you are going to have aggregation or you are going to have association. In my particular example, always, 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 if you can avoid using diamonds, the better. So I am going to do that. I am going to create a local variable, use association between these 2 classes. Yes, that is correct. From a design point of view, well, in general, in a programming point of view, always, always, always. If you have association, if you have composition aggregation, and if you have inheritance, if you can solve a problem and you can use any of them, priority, the best choice, association. Why? Low coupling. We need to talk about this later, but low coupling. Association is a lower coupling level than any of the others. So always, 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 if you can have a local variable instead of a global, that is better. Always, 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 if you can use association instead of the others, that is better. Good. In fact, the last option, the worst one, is using diamonds. Why? The coupling is not low couplet. When you have composition or even aggregation, the coupling is too high. We need to talk about that from a metric point of view, but just as an introduction, answering the question, this one is better, happy face. This one is not recommended. Mostly of your assignment 2 is about it should work. I am expecting that you give me something that works, compile and run. That is priority. Number 2, I am expecting you to follow the basic things that we reviewed before regarding modules and information hiding. That is priority. So I am expecting that all your methods are cyclomatic complexity 10 or lower. I am expecting you to have several methods, not just one big, very, very complex. That is kind of priority. But regarding your classes and how do you connect your classes, something that I am going to do is to review with you different solutions, your solutions, just like I did before with the other assignment. So I am expecting that you use the things that we already covered, information hiding and stepwise decomposition, obviously create classes that make sense. But regarding the connections, we are going to review things that are pretty obvious, but most of these details is something that is going to be included in the next assignment. So do not worry a lot about the connection between classes. Worry about stepwise decomposition, information hiding, and having good classes. Good. Okay. So looks good. And so far, I explained to you all my decisions using a picture. Source code. source code for student. The only thing that I need to do is student, classroom, and these tutors, right? 4 classes. All the other things are from a library. So I am going to start with the student. You already checked the graphical user interface that I showed you. Tell me, makes sense what I have here? You have a class student. You are importing 2 libraries. Number 1 is util, number 2 is swing. I could assume that swing because the graphics, and Java util, among other things, because observer and observable implementation. So hopefully 2 lines, fine. Your class is going to be a student. You are extending a panel. You are implementing an observer. And hopefully you know why. Panel, the graphics, observer, I need information from another class. Good. It is a panel, and something that you are asking me is that this panel show information. In order to show information, something that I can do is to use a label. So I am going to create an object label. That particular label in my implementation, I think that is going to be needed in more than 1 method. So just for my first draft, I am going to put that one as a global, just because I think more than 1 method is going to need it. So sorry, I need to have that label global, and global with a new, which basically means that if I go back here and I want to provide the details of that, it's like you have your class student and you have a diamond, and that diamond is connected with JLabel. I am going to use the JLabel for the data and black diamond. I have a constructor. In my constructor, nothing interesting here regarding the patterns. Background of the panel. I have this method set background. I am loading a new picture. I am including that picture in my label. And I am adding the label to the screen. All of this, the method add, the method set background, where those methods come from, why I am using those methods. I do not define those methods. Where are they? How is that I can access those methods? Could you agree with me that those are the methods that I am inheriting from the JPanel? Just because I do the extend of JPanel, I have access to this set background and add. Power of inheritance. I can do things that before, as a student, I cannot do, but now as a child of a panel, I can do. Inheritance. Okay, nothing fancy here, really. I have this method, answer question. I am going to receive as a parameter a string, and the only thing that I am going to do is to return the same string that I received plus some decoration. This one can be private. It's just a method that I am using to put fancy my string. So far, good. The important one, the important connected with being an observer. Just because you are an observer, you need to override the method update. That is the important one. And in the method update, you are going to receive as a parameter a reference to the observable. The observable. This method is going to be called when I am notified that something changed. When something is going to change? When the user writes something and click the button. In that moment, a notification is going to be sent to me. And that notification is going to include this reference. And I can use that reference to call this method, to ask the instructor, can you give me the question? I just get a notification that something happened there. I can ask for that. I can decorate. This is a call to this method, adding a string. And finally, who is labeled? This global variable. Remember, we are using that one in two methods. I am going to put on the screen the information that I received from the observer. The observer do something, I receive the notification, and I put the information on the screen. Done. It's like printing before, but now I am working with these graphical elements. Panel, observer. What is going to happen here? Well, I split tutor in two, the graphical part and the non-graphical part. Let's work with the non-graphical part. The non-graphical part is the one that is observable. In the observable, what I have is basically three responsibilities. Responsibilities, this one, that I already have it before, create a question randomly. And this one, about creating a question or getting a question from wherever, someplace, some variable. It doesn't matter the origin of the question. The important one here is when I call or someone call this method ask question, I am going to do this and this. It doesn't matter who or when call the method ask question in this class. Something that is going to happen is together with the question, together with the change of the information, I am going to establish that something changed, and I am going to ask to the observers to be notified. Those two red methods are the methods that I am inheriting from observable. Those two methods are the ones that are going to call this update here. Those are the two important ones. Again, tutor. Do whatever you tutor need to do, but in some point, you're going to call set change, you're going to call set notify observers, and you need to extend observable. Those three elements are the only new things that the template is asking you to do. Okay, the other part, the graphical one. The graphical part, my class, extend the panel. Panel is the one providing graphics, used like for a student. What is that? Answering the question in the chat, remember, if you have a global variable, doesn't matter that it's JPanel or any other type, the type is not important, but if you have a global variable, the UML diagram is going to have a diamond. Global variables are going to look like diamonds, aggregation composition. I am talking about global variables from classes, global references, not primitive data, right? So global variable in which the data type is another class, the relationship between the classes is composition or aggregation. However, if the variable is local, that changes the scenario. If the variable is local and you use the variable to call a method, just like the variable is an object and that object is needed to call a method, then your UML diagram is going to look like an association, an arrow, the line without the diamond. Good. Now, what happened here? Implement action listener. Why? Something that we ask here is, well, we have this element, the click, we need to handle. And in order to handle clicks, we need action listeners. And the action listener is going to be in this panel. The panel is the one that is concerned about the listener, not the full application. The panel is the one that is going to implement action listener. And we can put that also in our class diagram. It's like this guy, the tutor, the graphical part of the tutor is going to use action listener. Question in your exam, action listener, that class is going to be connected with which one other? I need to connect this guy to panel, tutor, classroom, observable. According with the source code that I showed you, this one is connected with this one, right? And the connection is a diamond, inheritance, association. Hopefully you can agree with that connection. It's inheritance, but action listener is an interface. Therefore, the line is not solid, but a dashed line. And that. Well, the name is realization. Remember, when we talk about generalization and specialization, it's between classes or between interfaces. But in this case, we have one interface, one class. Between them, the name realization. Tutor panel is a realization of the interface. Good? Yeah. Okay. I am updating my class diagram, new elements. I'm here. So this one, I need to connect the graphical part with the other part, with the non-graphical part. And you know what? I just discovered that I need tutor in this method, and probably I am going to need tutor also in this method. So I need the variable in two different methods. And just because of that, I need to put the variable global. And if I need to put the variable global, then I need to update my class diagram. What should I change in my class diagram now that I know that tutor should be global because more than one method need access to that variable? Anything to change here? I need to add a diamond. A diamond, black or white? Why white? I mean, I agree with you. The correct answer is white. I just want to be sure that we know why. Do we have a new for tutor in any place? It's not here. It's not here. I have no way to be sure that tutor is going to be different from null. And if my source code is not giving me that information, my diagram should be white. It's going to be aggregation, not composition. So white diamond. Good. Okay, white diamond. Following with the source code, I have here a constructor. The constructor is going to deal with all the graphical thing. I receive the tutor as a parameter. Someone is going to give me the other part. I am establishing a new background. It's going to be white. I am loading an image, the image of the professor. I am going to create and use a label. I am setting the icon for the label. That is going to be the image. I am going to ask the text field. I am going to ask the bottom, and I am going to add the listener. These three things, the space to write, the J bottom to click, and the listener that is going to be connected with the click of the bottom. So that listener, the action listener, just because I am implementing an action listener, I need to provide an action performed. What is going to happen when I click in the J bottom? this method action perform is going to be called. What this method is going to do is going to call this method in tutor. Do you remember what that method in tutor is going to do? Tutor.ask question. Do you remember what that method do? Call the observers. Did you notice the connection here? When the user, I am the user, and I go and click in the small OK button, I am going to call a listener. That listener is going to connect with the action perform method. The action perform method is going to call a method in tutor. The method in tutor is going to call all the update methods in all the observers. That is what happened. And just because that, the information in the text field is going to be sent to the observers. And the observers, one of them is the panel above me that need the information. Now, question in the chat, good point. Here, in order to complete my example, I did this. I have a question for you. Can I move those two, the text field and the J bottom, can I move them inside of the constructor? Yes or no? There is any other method using question and OK? According with this, no. So could I move them inside? Could be a recommendation that you could give to me, like, professor, move your variables inside of your constructor because no one else needs it. Yeah, move it. Now, if I move them inside, if I took these two and put inside, that is something that I should do. My class diagram, like this, should be something like this tutor panel is using a J bottom, and the tutor panel is using a J text field. If I move those variables inside of the constructor. Now, if I do not move them, if I do the diagram as my source code is right now, what is the difference? The diagrams, correct. This should be the solution. I should move my variables inside of the constructor. Again, locals are better than global. But if I give you the source code as I show you, and I ask you for the class diagram that corresponds to the source code that I show you is something with diamonds here. Moreover, do we have news or not in the source code? Yes, we have news. So this is the diagram for the source code. But again, as we mentioned before, this is no low coupling. You should not have black diamonds. I mean, the best recommendation is avoid the black diamonds. So in this particular case, it's very easy to remove the black diamonds. The diamonds, just moving the global variables to local. And we can do that because there is no other method that needs those variables. So just be aware of that. Clear? Hopefully, yes. Yeah, if you have two classes and those two classes, this one is calling methods in this one and the other is calling method in this one. So basically what you have is this bidirectional line. Remember, when you have two classes and you just connect with the line, the meaning of the line is this. When you put the arrow in one line, you are doing the connection unidirectional. But when you do not put the arrowhead, the meaning of a line without arrowhead is bidirectionality. So this line is this meaning. You have this class A calling methods in B, but also you have methods in B calling things in A. Just like showed you before with the Java. Good? Great. So the graphics, the observer, and the last thing is the main. Classroom. Classroom is a frame, the big window, the constructor. In the constructor, we're going to create the objects, tutor and student. We are going to connect tutor as being observed by student, and everything in green is just graphical things. The layout, in order to have 2 rows, 1 column, adding the panels to the screen, and in the main, create the frame, establish a size, and make everything visible. Done. Hopefully it was clear. My homework for you guys, please review the source code and be sure that you understand every single line, every single decision, and also compare with the class diagram. Be sure that you can create a class diagram for the source code and think about modifications in the source code and think about how that modification could impact the class diagram. I need you to be able to move from class diagram to source code, from source code to class diagram, and be sure that there is one and only one representation of whatever you do with the source code, or one source code for whatever class diagram I give you. Practice with this. Any question, let me know. We continue next lecture. Good? Okay, guys. See you next week. Thank you.